In this video, we'll be learning how to solve a system of equations word problem by using elimination. So now we're going to take our knowledge of elimination and apply it to a word problem. So let's just read through this together. It says a business has 2 locations and buys 7 larger delivery vans and 5 smaller delivery vans. Location A receives 5 large vans and 2 small vans for a total cost of $235,000. While location B receives 2 large vans and 3 small vans for a total cost of $160,000. Essentially what we're trying to figure out is what is the cost of each van. So add that in there. What is the cost of each van? So before we even begin, let's identify what we are looking for and ultimately trying to find in this problem and assign them to variable values. So here, one thing we're trying to find is the cost of a large van. So I'm going to denote that as X. And then we have Y, which is the cost of a small van. So those are my 2 unknowns that I'm trying to find by the end of this problem. So what I'd like you to do is I want you to write 2 equations for the situation above, and you're going to write one for each company. So each company here actually has like a cost calculating equation that's going to be written in standard form. So with this particular problem, we're going to write 2 equations into standard form. And these standard form ones are really where elimination is a great strategy to use. So location A, what I see is that location A receives 5 large vans. So my equation for location A is going to be 5 times X. So I have 5 large vans times the cost of a large van plus 2 small vans times the cost of a small van, which is Y, is equal to $235,000. So that's how the cost is calculated for location A. 5 times the cost for a large van plus 2 times the cost for a small van is equal to $235,000. Then if I look at example B, or location B, we have 2 large vans times the cost of a large van plus 3 small vans times the cost of a small van is equal to $160,000. So here we can write one equation for each company. We have the equation for location A in red and the equation for location B in blue. So now here, because this is set up in standard form, elimination is a good strategy simply because it's already rearranged into columns. It's already kind of set up for us to be successful using elimination as long as we can get those coefficients to match. So here we need to pick a variable that we want to eliminate. And I'm going to pick Y. Doesn't matter which one you pick, I am just going to pick Y. Now remember, we need to think about, okay, what will that common coefficient be? It's like picking a common denominator, which in this case is going to be 6. So here I need one of these to be a positive 6 and one of these to be a negative 6. So I'm going to start by rewriting these, thinking through, okay, what would I need to multiply that first equation by in order to get the coefficient of Y to be 6 or negative 6. And what I see here is that if I were to multiply this first equation through by a positive 3, my coefficient of Y will become 6. So if I multiply through everything by 3, I end up with 15x plus 6y is equal to 235,000 times 3, which is 705,000. So now I've rewritten one equation and I've used up the positive 6. So now I need this second equation to have a coefficient of negative 6. So I'm going to multiply everything here by a negative 2 to make that 3y become a negative 6. So 2x times negative 2 is negative 4x plus 3y times negative 2 is a negative 6y is equal to 160,000 times a negative 2, which is a negative 320,000. So now I'm going to utilize the elimination strategy since it's set up for elimination by adding the two together. So 15x plus a negative 4x is 11x, plus 6y plus a negative 6y is 0y, so I'm not even going to write that in there for very long. And then I have 705,000 minus 320,000, which leaves us with 385,000. So really here I have 11x is equal to 385,000. And then if I divide that by 11, I find that x is equal to 35,000. Now we need to think about what x represents in the context of this problem, and x is the cost of a large van. So what this is telling me is that the cost of a large van is $35,000. So I've now found one piece of the puzzle. I know that a large van costs $35,000. So now what I'm going to do is I'm going to take this value and I'm going to substitute it back into one of these two equations. And it doesn't matter which one we pick, so I'm just going to pick the smaller one because it has some smaller numbers. So here, if I do my work over here, I have 2 times the cost of a large van, which is $35,000, plus 3y is equal to 160,000. So 2 times 35,000 is 70,000. If I then subtract 70,000 from each side, I end up with 3y is equal to 90,000. Divide both sides by 3, and I find that y is equal to 30,000. Which then if I think about that in the context of the problem, that represents the cost of a small van. So by using the elimination strategy for these two situations, I was able to find the cost of a large van is $35,000 and the cost of a small van is $30,000. So then from here in part 3, I want to apply this information to a new situation. So what would my total cost be if I purchased 11 large vans and 7 small vans? Well, we can just use the two values that we found concerning cost. So I would take 11 times 35,000 plus 7 times the 30,000 for a small van. So then if I calculate that using my calculator, 11 times 35,000 is 385,000 plus 7 times 30,000 is 210,000. So if we add those together, if I were to make those purchases of 11 large vans and 7 small vans, I would spend a total of $595,000 on my vehicles.